In some questions, you may be asked at the end to compare the data that has been presented to you. So the first thing you need to look at in terms of that is the marks that are awarded for that question. So generally speaking, the more marks, the more they expect you to say, and that will give you some clues. Now, the other aspect to this is that they will expect you to give the numbers that you've calculated in your remarks, and sometimes they may expect you to give a real world interpretation of your comparisons as well. But for the most part, when they're asking you to compare data sets, it means either using the mean and the range, or the median and the interquartile range. It'll be obvious which of those pair they expect you to use given on what you've been asked to work out previously. So in each case, you're giving a measure of the centre, the mean or the median, and a measure of the spread, the range or the interquartile range. Now, another element that might be involved with comparing data sets is skewness. Now this, I think, is more likely to come up if you have to do the GCSE in statistics, the separate qualification, but it doesn't hurt to know it. So this picture shows a graph that has no skewness. In other words, it's symmetrical. So the opposite of being skewed is being symmetrical. This one here is positively skewed, and this one is negatively skewed. So what does that mean? So if it's positively skewed, then what you can see is that most of the data is down here in this lower range, whereas if it's negatively skewed, then it's more likely to be up here. Now, one way you might be able to tell if it's positively or negatively skewed without seeing a graph of it is in terms of comparing the mean and the median. So generally speaking, if it's positively skewed, then the mean will be greater than the median. So remember, the median is always just halfway through the data, wherever that happens to be. And the mean is the average that you get. And if we look at the negatively skewed one, then it's the other way round. The mean will be less than the median. So might not come up if you're just doing the regular GCSE in maths, but if you're doing the statistics one, then you might need to know about skewness. So let's just look at an example and give you a flavour of how you might word your comparisons and what you might say in there. So we've got some data that's been already worked out here, and just factor in that normally in terms of your marks, if you haven't already been asked to work the statistics, the mean, the range and so on out previously and get marks for them, then they will possibly be part of the marks that you get for the comparison. So if you get a question that's got maybe 5 marks for the comparison, then that typically will mean that you're supposed to have worked out the mean or the range or whatever beforehand, and part of that will actually add to your marks. So here I've got a table of the times it takes men and women to run 100 meters, and those times are given in seconds. So I've just done a comparison using the mean and the range. You could just as easily substitute the words median and interquartile range, change the numbers to fit. It would work just as well. So I've said the men's mean time was 0.87 seconds faster than the women's mean time. So that's just a description of what we can see, but notice I included a numerical fact in there. And so then for an interpretation, I've said on average, men run the 100 meters faster than women. That's, if you like, the real world application of what we've noticed. And then the range for the men was 0.62 seconds lower than the women's range. And that means that the men's times are less varied than the women's. Now, just because we've mentioned skewness before, and for those that this might be applicable to, because the mean is less than the median in this particular table for both the men and the women, that would imply that there is a negative skew, namely more men and women take longer than the mean time.